All right, now we're going to talk about molar mass. Last time we talked about the mole, and we did this problem up here, where the mole was 6.02 times 10 to the 23rd is 1 mole. And remember that mole is like a dozen, right? Well, now we're going to look at the mass of a mole of stuff. All right, now if I sent you again to the Myers and I told you to get me a dozen donuts, well, we could also measure that dozen donuts by what's the mass of those donuts, right? So we could actually measure out what's the mass of 12 donuts, and then that would be how much you would get me. And assuming the donuts were always made exactly they're the same donuts, well, then we're going to assume that mass would always be the same. I know that can vary a little bit, but we're going to assume it would be the same. So how molar mass works, and again, you should have your notes in front of you, is that it's the mass of 1 mole of particles. So it's the mass of 6.02 times 10 to the 23rd particles, whether it be atoms, molecules, formula units, whatever it is, but it's the mass of that amount. Okay? So in our notes I had down, if we looked at carbon way back when we did the electron configurations and we learned how to do proton, neutron, electrons, we could look up carbon on the periodic table and go, well, carbon's atomic mass is 12. So for 1 atom of carbon, its mass is 12, but it's not grams, it's 12 AMUs, atomic mass units, because it's that really small number. Well, what scientists figured out many years ago is if we take 6.02 times 10 to the 23rd atoms of carbon, so we take that whole bunch of atoms of carbon, well then now it's not AMUs, now it's grams, and it's actually 12 grams. So we can pull off that periodic table, we can use the atomic mass, and instead of using as AMUs, we can use them as grams, as long as we're assuming that we have that chemist's dozen of those particles. All right. So things aren't changing. All we're changing is the units that go on this. That now we're going to change it into grams instead of AMUs. So we do some examples of this, and again, these are in your notes. So we have NaCl, table salt. If I'm going to try and figure out the molar mass of this, so if I have 6.02 times 10 to the 23rd formula units of this, because this is an ionic compound, well, how many NAs are in that? Well, there's 1. So there's 1 Na. So I go to the periodic table and look up his mass, which is 23. So I go 1 times 23. Then I'm going to add that to how many chlorines are in this thing? 1. And his mass from the periodic table is 35. So 1 times 35. So 1 mole of formula units of this thing is going to be 23 plus 35, which happens to be 58. And that's not AMUs now, it's actually 58 grams per 1 mole of NaCl. Right, so if I have a mole of this stuff, I'd have 58 grams of it. Or if I have 58 grams of it, then I actually counted 6.02 times 10 to the 23rd formula units of NaCl. So now I don't have to count, I can use mass in order to count. All right? And that's really what chemists do all the time now. We don't really count. What we do is we utilize masses in order to count things. The second one I got in your notes was water. Well, in this one, how many H's are there? Well, there's 2. So it's 2 times the mass of hydrogen, which is 1 from the periodic table, plus there's an oxygen there, so 1 oxygen times his mass is 16 from the periodic table. That's everything that's there. Now I add all this up, so this is 2 plus 16, so that's 18 grams per 1 mole of water. So that's 18 grams of water per 1 mole of water. All right. This next one, this one's not in your notes, but I'll do it anyways, is if we had C6H12O6, which is glucose from biology. So how many carbons are there? There's 6 times his mass is 12 from the periodic table. Plus how many hydrogens are there? There's 12 of them. Times his mass is 1. Plus how many oxygens are there? There's 6 of them. Times his mass is 16. So now what we'd have to do is we'd have to multiply all this. Oops, there goes my lights. Hold on. Tell I'm doing this in the morning when it's dark. All right. So if we multiply this thing out, we'd get, this would be what? 72 plus 12 plus this would be 96. Now what I'd have to do is I'd have to add all this stuff up. Oh my goodness, that'd be what? 84. That's 84 plus 96. So that's like 180 grams of C6H12O6 per 1 mole of C6H12O6. So if I have 180 grams of glucose, then I have 1 mole of these guys up here, molecules of C6H12O6. Okay. All right, well, the next piece is in your notes says types of molar masses. Now, molar mass, that word molar mass is kind of like ketchup. I know we talked about this way back once before, that ketchup is kind of a generic term. If I tell you go to the Myers and get me a bottle of ketchup, you go on that aisle and you go, oh my gosh, there's so many different ketchups. Which kind does he want? All right, because there's Heinz and Hunt's and Meyer and Great Value. There's so many different kinds. All right, well, just like in this one, molar mass is like saying ketchup, right? But we can also be more specific and say, well, I want to know the gram formula mass. Well, gram formula mass, that would be for a formula unit of an ionic compound like NaCl. Right? Gram molecular mass is for a molecule or a molecular compound like water or like C6H12O6 that's made up of nonmetals. Then we can have gram atomic mass, and that's for an element like carbon that we did just a minute ago. Right? So if you notice, every single one starts with gram, it ends with mass. It's that middle word that changes. So we got formula, that's a formula unit. Molecular, that's a molecular compound, and atomic is an atom. Now know that no matter what it says, you're doing the same thing. All you're going to do is take their molar mass, or take their mass off the periodic table, put grams after it, that makes the molar mass. So every single one of those things is a molar mass. You're still doing it exactly the same. All right. Okay, so with that, we're going to do some molar mass calculations. And on that one, going through your notes there, it says molar mass calculations for water is that if I figure out the molar mass of water, which we just did a minute ago, remember it was 18 grams per 1 mole because there's 2 hydrogens times 1. So I'll do it up here real quick. I got 2 hydrogens times 1 plus 1 oxygen times 16. Well, that's 2 plus 16. That's 18 grams of water per 1 mole of water. Well, what happens if I have 2 moles? Well, I put an equal sign here because we can go to the other side of this and go, well, I don't have 1 mole, I got 2 moles of water. And I'm going to put X on top and try and figure out what's its mass. So I would cross multiply and go X times 1 equals 18 times 2. And that would give me 36 grams of water, would be 2 moles of it. If I double those moles, then I would have 18, or I'd have 2 times 18. Oh, that's what we did down here, 2 times 18. All right. Now, what if that's really probably when I did that, if you're really good in math, you probably figured that out before I did. And so, yeah, that's like 36. I can figure that out. But what if we had 7.3 moles? Well, that's a little harder to do in my head. But we can still do it because we're still going to use the same ratio we had before. But now instead of 2, we're going to have 7.3 moles of water. So I'd go X times 1 equals 18 times 7.3. And then I could type that in my calculator because I always have my calculator because I always have my computer. And I'd end up with X equaling 131.4 grams of water. And is that per 1 mole? Nope, it's not per 1 mole. It's actually per 7.3 moles this time. All right, if I have 7.3 moles of water, then I actually have 131.4 grams of it. All right, now what if I changed it to, I want to know if I got 60 grams of water, how many moles is that? Oh, that changes things, kind of. It's going to change this side now. Now I'm not giving moles, now I'm giving grams. So grams are on top. So I got 60 grams of water. I want to find out X moles that is. So I'd cross multiply and go 60 times X. Oh, sorry, I made a mistake there. That's 60 times 1, isn't it? Then I got 18 times X. So going this way and that way. Now I got to get X by itself, so I divide 18 on both sides. That lets me cross that out. And X ends up equaling 60 divided by 18, which turns out to be in your notes 3.3 moles of water. I'm looking at it and go, well, does that look right? Well, 18 is 1 mole. 18 went up to 60, so 1 should have gone up. Yep, it did go up. It went up to 3.3. So that sounds good. All right. So depending upon what I give you, there's two things you got to look at. You got to look at what's the substance. In this case, it was water. So you got to find out that molar mass to get this ratio over on this side. Okay? And then you go, what are they asking for? Are they giving me grams? Want to know moles? Are they giving me moles? They want to know grams. And we put that on the other side. Okay? And the way in which I usually do this is when I write out this equation to be used in anything, I put down question mark grams over 1 mole equals, actually I do a double question mark, then I go question mark over question mark. So we got to find this thing out first for what that substance is. We got to find out its molar mass. Once I know that molar mass of that substance, then I can go over here to the question and put in my number and my x in order to solve for it. So jumping back now to our notes, what if I changed it from water to sodium chloride? And I want to know 60 grams of sodium chloride. Oh, now I got to go all the way back and go, well, sodium chloride is NaCl. There's 1 Na times 23 plus 1 chlorine times 35. Add all that up, I get 58 grams. Oh, so that would go in this spot right here. So I'd end up with 58 grams in the double question mark. And then we say, well, what if I got 60 grams of it? Well, that would go over here. So I'd have 60 grams of NaCl. And I want to find out X moles of it. So I'd have to cross multiply. If I cross multiply, X would end up equaling. Sorry, let me go to my other page here. I'll save myself some time. Cross multiply and solve, you'd get 1.03 moles of NaCl. All right, so in order to do these, you got to find out what this number is based on what the compound is, and then you have to put it on the other side from the question. Okay, it's a little bit of work, but I got faith. I think you guys can all do it. So we're going to do some of these for a day or two, and we'll see if we can get these things down. So we'll see you.